So the next demo to look at would be this rigid body CCD, or continuous collision detection. But this demo was made to look nice, but is not actually a good way to explain the feature. So we're probably going to replace it. For the time being, let's look at the box on plane demo again, and I'm just going to modify it for continuous collision detection to explain the feature. So we've seen this one before. It's basically this box dropping down on this flat plane, and as you have seen, it drops pretty slowly. So it's not a problem for the collision detection system to detect the collision. But let's see now what happens if we make this box fall way faster. So we're going to give it an initial velocity of, let's say, negative 2000. And I'm going to come down here closer to the ground, and let's see if it still collides. So yes, it still just about collides. Let's actually look at that collision in slow motion. If you go into this physics debug pane that you can access from physics debug right here, then you can just step the simulation frame by frame. So if I click here, it will just simulate one time step and then stop until I press again. And you can see here, it actually just moves into the plane. It executes basically its collisionless translation according to its velocity. But then here it detects the fact that there was a collision and it recovers. So it pushes the objects apart. This is the standard behavior of physics. Now, this works up to a certain point, but if I continue to increase the velocity of the object, let's say we go to 3000 here, and then we also, again, step here, it's done another one, and now you can see most of the object has gone through this ground plane, which is actually a mesh. It's not a plane. If we would have used the create physics ground plane, which actually creates a half space, this would still be recoverable. But because a mesh doesn't realize that it's not supposed to just be emptiness on the other side, this is no longer recovered from. And if I take another step, the box has just fallen through the other side, which is, again, for meshes, it's being treated as empty space. So how can we stop that? What we can do is enable continuous collision detection. So there's actually two parts to doing that. First, on your physics scene, you have to enable the overall continuous collision detection feature right here. And then on the box actor itself, you have to go down to the rigid body, roll out and enable CCD for the particular object. And now, if you simulate, you can see it stops right where it starts colliding with the other object, and from now on it just continues. You know, the initial velocity is lost in the collision and it settles down. That's basically what the continuous collision detection is for. It's basically if you have either very, very small objects or very large velocities. The main point is that the distance that it moves per time step is going to be way more than the size of the object. Then you need to have this feature to detect collisions reliably anyway. There is actually a less expensive, computationally expensive version of continuous collision detection here in the advanced options. So if I disable CCD again, actually let's reset the simulation here. You disable the regular CCD, and then there is also a speculative CCD. This one is maybe a bit less reliable, but it's also computationally less expensive, and it doesn't need you to enable the CCD feature on the scene. So let's see how that one behaves. This is, again, a very very gentle case because our velocities isn't like all that enormous, and also it's a really big object that it's trying to collide with. So even this lower cost CCD is going to reliably catch the collision like you see here. So that's basically how you use the continuous collision detection feature in